In this video, we're going to take a look at circles, intersections, and the segments. So there are three types of scenarios that can happen. In the first type, we have intersecting chords or secants. So notice in this first picture, we have two chords that intersect inside the circle, but not at the center point of the circle. And so the rule for this intersection is we would say that on that same segment, so let me color one of them with a different color to show you what I'm talking about. So we would say to figure out the length of a missing segment, we can say A times B. So the two parts that are on that same chord are equal to the other two multiplied together. So A times B would equal C times D if you have two chords or two secants that intersect inside the circle. All right. Type 2 is when you have intersecting secants outside the circle. And so there's secants because they go through the circle and keep going. And then they intersect with each other outside the circle. And so for this scenario, you would multiply A times A plus B. So that outside piece times the sum of the whole secant is equal to, again, the outside of the other secant times the sum. And so you would say A times A plus B is equal to C times C plus D. And we'll look at some examples of that in a minute. And then the third scenario is if you have a tangent and a secant. So notice that tangent leaves you with one little piece on the outside. So you would just say A squared in this case is equal to B times B plus C. The little outside piece on the other side on that secant times the sum of the whole secant. All right, so these are the only three things we need to talk about in this video. So we're going to look at a few examples of each of those types of intersections. So on number 1, this is considered like a type 1 type problem because these two chords intersect inside the circle. And we would say 14 times 15, because those are on the same chord, would be equal to x times 10, because those are on the same chord. So it's a pretty straightforward example of that first type of intersection. So 14 times 10 is equal to 210. And on the other side, we have 10x. And so we just have to divide both sides by 10. And we get x equals 21. And then we only needed to solve for x. So that's it for example 1, which was a type 1 problem. Example 2 is another type 1 problem. So the same thing would happen here. We have 27 times x plus 5. Because those are on the same chord. We multiply those two segments together. And then that would equal 24 times x plus 7, because those are on the same chord as well. And we multiply them together. So then we just need to solve for x after that. So I'm going to distribute x and get 27x plus 135 is equal to 24x plus 168. Okay, so I'm just going to finish solving with this one color just to save some time. So 27x minus 24x would leave us with 3x plus 135 equals 168. Let's subtract 135 from both sides. So we get 3x is equal to 33. And then divide both sides by 3. So we get x is equal to 11. All right. So those are both type 1 scenarios. Number 3 and number 4 are both type 2. So let's take a look at some of these. So if we have a secant, so it goes through the circle and outside of the circle, and then another secant does the same thing, and it leaves you with these little sort of outside segments. So I would say that outside piece, which is a length of 10, times the sum, which is 10 plus 42 for this one, is equal to this outside little piece on the other secant, and then times the total, which is x plus 13. So it's like the outside times the total is equal to the outside times the total. So the same thing on both sides. All right, so we get 10 times 52, which is 520 on that side. And then we get 13x plus 169. And we can just finish solving for x. So let's subtract the 169. And we get 351 equals 13x. And then divide both sides by 13. And so we end up with x is equal to 27. Now, they did ask us to find NL, which was the total. So we do need to plug that back in. So 27 was this part, but we need to add it to get the total of NL. Let me erase that so you can see it better. So 27 plus 13 would be 40. So to answer this question, we just needed to plug it back in. So we got NL equals 40 because x was equal to 27. All right, so let's look at another example of a type 2 problem. So we have a secant intersecting with another secant, which creates these little outside segments. So we have 8 times the sum of the whole secant. So 8 times 8 plus 3x plus 4, I'm just going to write it all out, equals 7 times the sum of the whole secant. So 7 times 7 plus 5x plus 2 is our setup. All right, so let's work on combining like terms. So we have 8 times 3x plus 12 equals 7 times 5x plus 9. And then let's distribute. So we get 24x plus 96 is equal to 35x plus 63. And then we're just going to keep solving for x. So let's subtract 24x. So we get 96 is equal to 11x plus 63. Subtract 63, so we get 33 equals 11x. And divide both sides by 11. So we get x equals 3, and then that is all that they were asking for. So we can stop there. And let's move on to, let's see, two examples of type 3. Okay, so for type 3, we have a tangent and a secant that meet outside the circle. So they intersect outside the circle. You take this one little piece and square it. So that little outside piece squared equals the outside times the sum again. So we'd say 8 times 8 plus 5x minus 1. And then 16 squared is 256. And that would be equal to 8 times 5x plus 7. And then if we distribute, we get 40x plus 56 equals 256. So let's subtract 56 from both sides and get 200 equals 40x. Then last but not least, we can divide both sides by 40 and we get x equals 5. And they asked us for Pn. So let's see, Pn means we got to take x and plug it back in to get Pn right there. So 5 times 5 minus 1, which is 25 minus 1, gives us Pn would equal 24. All right. So let's look at another one. Number 6 says solve for x. And again, we have a tangent, this little piece out here, and a secant. And they intersect outside the circle. So take that tangent piece that's by itself and square the 3x. And then multiply that by the outside, or excuse me, set it equal to the outside times the sum of that other side. So 9 times 9 plus 16, in other words. And then 3x squared is equal to 9x squared. Don't forget to square the 3. Then 9 times 9 plus 16 is the same thing as 9 times 25. So 9x squared, because remember that's 3x times 3x, would give us, let's see, 225. And we just need to divide both sides by 9. So we get x squared is equal to 25. And then when you take the square root, we would normally say x equals plus or minus 5. But since x in this case would make this a negative length if it were negative, we would just say that x is equal to the positive 5. So that is it for number 6. Let's see, I think we have 2 more quick examples to take a look at. So for this one, it's back to a type 1 problem. We can say that these chords intersect inside the circle. So 12 times 10 would equal x minus 1 times x plus 6. All right, and so what we end up with is 12 times 10 is 120. We would have to FOIL these two binomials together. So whichever method you prefer, you would take those and FOIL them. And we would end up with x squared plus 5x minus 6. But then this is a quadratic equation at that point, so you've got to treat it that way and get everything on one side and then use one of your methods of solving quadratic equations. So let's do x squared minus 5x minus 126. All right, and then I'm going to factor it because that's usually the quick, easy way to get it worked out, but there are other ways. So if you multiply to get negative 126 and you add to get negative 5, negative 9 times 14, or excuse me, that was a positive 5. I meant to bring down a positive 5. My fault. So negative 9 times 14 were the numbers that I got. That's how I knew I had made a mistake right there. So I have x minus 9 and x plus 14 for my factors. And then remember, with factors, you set them equal to 0 to finish solving the quadratic equation. So x minus 9 equals 0 and x plus 14 equals 0 would give me that x could equal 9 or x equals negative 14. But then negative 14 would not make sense with our figure. So that is an extraneous solution. We just get x is equal to 9. Okay, so one more example. So this one is one with 2 secants. So we would say the outside times the sum of the whole secant. So x times x plus 5 will equal, again, the outside, which is 4, times the sum of the whole secant. So 4 times 4 plus 2. So let's start solving for x. We could distribute and get x squared plus 5x. And then that would equal 4 times 6, which is 24. And so let's put everything on one side because it's quadratic again. So once you notice you have x squared and it's not going to cancel out or go away, you have a quadratic equation. So you want to get everything on one side equal to 0. And then I'm going to try to factor it again. So I got to multiply to get negative 24 and add up to get 5. And so 8 times negative 3 and 8 plus negative 3 would be the numbers I need. So I've got x plus 8 and x minus 3 are my factors. And so x plus 8 would equal 0 and x minus 3 would equal 0. So x equals negative 8 and x equals 3 are my possible values for x. But x can't be negative again. So a lot of times that's the case with geometry because it wouldn't make sense for the length of a segment to be negative. Okay, so that's it for these examples. Thanks for listening.